All right, guys, today we're going to be covering 7.6 trigonometric inverses. This should actually be 7.4. So we're going to be covering 7.4 trigonometric inverses. This is Unit 7, right triangle trig, and our learning target is I can solve right triangles using trigonometry. So what we were covering yesterday was just solving triangles using trigonometry. And what that allowed us to do was solve for our missing side lengths. Now, the difference between those problems and this problem is this time we don't have an angle measure, and we need to solve for this angle measure instead. So we're going to come back to this problem a little bit later today. And in order to actually solve for that angle measure, we first want to talk about inverses. So, inverses. What is the inverse of 2/3? Well, if it's an inverse, then we just flip the fraction over, and the inverse of 2/3 would be 3/2. What happens when you multiply inverses together? Well, when you multiply an inverse by its inverse, you end up with 1. They cancel each other out. So 2/3 multiplied by its inverse, well, that would just give us 2/3 times 3/2. I multiply straight across, giving me 2 times 3 over 3 times 2, which gives us 6/6, which of course is just equal to 1. So when we multiply by its inverse, it ends up being equal to 1. And as we can see, this cancels out perfectly. So if I want to solve for inverses, if I want to get rid of a number, I can just multiply by its inverse. Now, what does that have to deal with today? Today, we are covering inverse trig functions. And trig functions also have inverses. You probably have already seen them on your calculators. For instance, the inverse of sine is sine to the negative first power. This is what it would look like on your calculator. The inverse of cosine is cosine to the negative first power. And the inverse of tangent is tangent to the negative first power. So these are our inverse trig functions. And if we recall, the normal trig functions that we were doing the last few days, the normal trig functions, those were used to solve for missing side lengths. So that's what trig functions were used for. Inverse trig functions, however, those will be used to solve for missing angles. So each of these trig functions here that's shown, these will all be used only to solve for missing angles. So when they ask what are inverse trig functions used for, you can always answer they are used for finding missing angles in right triangles. Now, down here, we have triangle ABC. First off, we know it's a right triangle because we see the 90-degree angle, and we have this missing angle over here, angle A. Now, a couple things. Again, this only works for right triangles. So if we don't have a right triangle, we can't use this. On top of that, theta, that symbol that's shown for angle A, theta is just used to show angle measures. So if you see a theta, that means that you're solving for that angle. So we see that angle A is theta, so that's the angle that we'll be solving for. Now, again, we're going to set up our triangle just like we normally would for a trig function. The only difference is now we're solving for theta instead. So we start this off by looking at what angle we're given. Again, I'm going to go back. It's theta that we're going to look at. We're going to label our triangle based upon theta. So I'm going to go ahead and throw up some numbers here. I'm going to say BC is equal to 3 and AC is equal to 4. That way we have some numbers on here and we can try a practice problem out. So, labeling up our triangle, that's the first thing that we'll want to do is label each side based upon that angle. 3 will be opposite, blank will be hypotenuse, and adjacent will be 4. Oops. So again, hypotenuse is blank, opposite is 3, and adjacent is 4. If we look at SOHCAHTOA, the only one that has opposite and adjacent is TOA, tangent. So now we can go ahead and set up our trig function. That's going to be our next step. Now, since we're using tangent, we'll have tangent of our angle, theta, is equal to 3/4. Now that we have this, we need to get rid of tangent around the theta. We want just theta by itself, so we need to get rid of this tangent here. So how do we get rid of tangent? Well, we talked about it earlier. We get rid of tangent by using inverses. That's the only way that we can get rid of tangent. So I take the inverse tangent of both sides. What this allows us to do is cancel out inverse tangent and tangent, leaving us just with theta. So theta is equal to the inverse tangent of 3/4. This is what you're going to enter in on your calculator. Now to enter in inverse tangent on the calculator, if you have a TI 83 or above, you're just going to hit second in the top left corner, and then you're going to hit tangent. What that will do is that will give you inverse tangent. If you enter this in on your calculator, inverse tangent of 3/4, you end up with 36.86989,765, and then it continues on forever. We're just going to round to the nearest whole degree measure, which will give us theta is equal to about 37 degrees. Now, again, for these, very important that you guys are within degrees and not radians. So if you're not getting 37 degrees, let me go ahead and check what else you would get if it's in radians. If you're in radians, you would get, let's see. If you're in radians, you get 0.6435. So if you're getting a really small number that doesn't make sense for an angle measure, you're probably in radians and just need to switch your calculator over to degrees. Again, if you have a TI 83 or above, all you need to do that is hit the mode button. And then you're going to use your arrow keys in the top right to move down to degrees. And then you're going to hit enter. And that will set your calculator to degrees. All right, let's go ahead and try out another one. Next up, we're going to find the measure of angle D. So we can see that angle D is theta. So we start this off by labeling up our triangle as opposite, adjacent, and hypotenuse. 11.2 will be opposite. 20.1 is hypotenuse. That's opposite the right angle. Opposite the right angle. And then adjacent is blank. So which trig function uses opposite and hypotenuse? Sine. So sine is equal to opposite over hypotenuse. So therefore, we're going to use the sine function. This will give us sine of theta is equal to 11.2 over 20.1. Again, we want to get theta by itself. So we're going to multiply both sides by the inverse of sine. Doing so, we'll cancel out the sine function and the inverse sine function on the left side, leaving us with just theta equals the inverse sine of 11.2 over 20.1. At this point, this is what we're going to enter in on our calculator. So we hit second sine 11.2 divided by 20.1. That will give us 33.8633, and then it's irrational, so it continues going on forever. We round to the nearest whole degree, giving us theta is about 34 degrees. All right, let's try out one more inverse trig function. Next up, we're going to find the measure of angle E. So we can see angle E up here. So the first thing that we want to do is we want to label our triangle based upon angle E. The side opposite angle E is DF, it's blank. The hypotenuse is 16.2, and the adjacent side is 5.7. Out of all of our trig functions, which one uses adjacent and hypotenuse? Because again, that's all we have on the triangle. I don't have any values for the opposite side. So I'm just using adjacent and hypotenuse. Well, that would be cosine. Cosine is equal to adjacent over hypotenuse. So if we set up our trig function, we'd get cosine of theta equals adjacent 5.7 over hypotenuse 16.2. From here, we need to get rid of cosine so that theta is isolated by itself. And the only way to get rid of cosine is to multiply by its inverse cosine. Now you may also hear it called arc cosine. All these inverses may have the word arc in front of them. It means the same thing. So I multiply both sides by the inverse of cosine, and that will leave me with theta is equal to the inverse of cosine of 5.7 over 16.2. From here, I can enter this in on our calculator. Entering it in on the calculator, 5.7 divided by 16.2. Oops, missed a decimal spot there. That'll give us 69.39937,545. And again, it's irrational. It continues on forever. So we round to the nearest whole degree, giving us theta is about 69 degrees. All right, that is it for inverse trig functions. Next, we're going to talk about angles of depression and angles of elevation. So first off, we have an angle of depression here. It's called an angle of depression because you're looking down from an angle. So I'm up in the plane, flying the plane, I'm looking down at the runway so I know where to land. So therefore, this is an angle of depression. Now, pay special attention to the orientation of this triangle, because that does matter. When I'm drawing my triangle for the angle of depression, I always draw out from my observer and then down from there. The reason that we do not want to draw down first and then over, well, as we can see, this whole thing is a big rectangle. And is this green angle up top here congruent to this other angle? Well, no. The only way that these two angles would be congruent is if this were actually a square. So that's why we need to be very careful when we're drawing up our triangles. Because let's just say that I throw in some numbers here. Let's say that this is 900. Don't want that. Let's say that this is 900 and this is x, which means that this is 900 and this is x. Well, if I were to set up my trig functions here, for the top angle, for the actual angle of depression, this would give me tangent of 900 over x. Tangent is equal to 900 over x. Let me go ahead and fix that. Tangent of theta equals 900 over x. If I look at this other one down here, this triangle, this would give me tangent of theta equals x over 900. As you can see, these are not the same values, so you would get the wrong answer. So it's very important you always draw outward first and then down. If you don't, you're going to cause a mistake because this should be the correct setup for this type of problem. All right. Next up, we're going to go ahead and talk about angles of elevation. So if an angle of depression was looking downward, an angle of elevation is when the observer is looking up. So here's an angle of elevation, someone with their binoculars looking up at some birds. When the observer is looking up, you have an angle of elevation. Now, again, pay special attention to the orientation of the triangle. For this triangle, I draw outward once again, and then since it's elevation, I draw up. So always draw outward, and then up if it's elevation, down if it's depression. So that's how you set up these types of problems. So let's go ahead and see what one of these problems looks like. Find the horizontal distance between the balloon and the observer. If the observer's neck is bent 43 degrees and the altitude of the air balloon is 1,723 feet. So to get started on this, I need to draw a triangle, a right triangle. Is this going to be an angle of elevation or depression? Well, that depends on who's observing, who's looking. Well, the observer is the one looking, they're bending their neck. So they're looking upward at 43 degrees. which means it's an angle of elevation. So therefore, I'm going to go ahead and draw my right triangle. I draw outward, then up. So here's my triangle. We know that the altitude of the hot air balloons is 1,723 feet. We want to find the distance that we are from being underneath the hot air balloons. So we're looking for this distance here, the horizontal distance, x. And we know our neck is bent at 43 degrees. So our angle of elevation is 43. At this point, we need to ask ourselves an important question. Are we going to use trig functions or inverse trig functions? And that's very important. And it depends on what we're solving for. If we're solving for a side, we use trig. If we're solving for an angle, we use inverse trig. Looking at this, we're not solving for an angle, we're solving for a side. So therefore, we're going to use trig. We already have our angle. We're not trying to solve for an angle. Since we're solving for a side, we're going to use trigonometry. No inverses here. So let's go ahead and label our triangle based upon the angle that's given, 43 degrees. The side opposite of 43 is 1,723. The hypotenuse is blank. And then the adjacent side is x. From here, we need to determine which trig function we can use based upon what is given on the triangle. Well, we have the opposite side that has value, and the adjacent side has a value. The hypotenuse is just blank, so we ignore it. So we're using opposite and adjacent. The only one that has opposite and adjacent is tangent. So we'll have tangent of 43. We'll have tangent of 43 equals opposite 1,723 over x. From here, we're just going to go ahead and solve for x. We start by multiplying both sides by x. This will leave us with x times tangent of 43 equals 1,723. Now again, we're going to treat tangent of 43 as a number. That way we can move it away from the x that's being multiplied by it. So I'm going to divide, to get rid of this multiplication, I'm going to divide both sides by tangent of 43. On the left side, tangent of 43 will cancel, and we'll just be left with x. On the right side, we have 1,723 divided by tangent of 43. We can enter this on our calculator. Doing so will give us x is about 1,847.7 feet, which means that they're 1,847 feet away from being directly underneath the hot air balloons. All right, let's go ahead and try out our final question of the day. Find the horizontal distance between the ship and the observer. So we have our ship over here, our pirate ship, and we have our observer up top. They're just looking down, watching what's going on, seeing how close that ship is going to get to the cliffs. We can see that they're 360 meters above the sea level. So that's how high up the observer is. That's how large our triangle is over here. So I can automatically put 360 on this other side because I know that's going to be the same height. Next, we need to determine whether this is an angle of elevation or depression. Looking at the triangle, this is an angle of depression. They're looking down 28 degrees. They need to look down at this. And also the triangle is drawn outward and then down. So we know that this is an angle of depression. So at this point, we're going to go ahead and label up our triangle based upon our angle measure. So looking at the angle that's given to us, we label opposite, hypotenuse, and adjacent. The side opposite 28, I move through my triangle, is 360. My hypotenuse is blank, and my adjacent is x. At this point, let's go ahead and determine which trig function we want to use. Well, what's given on our triangle, which has value? Side opposite has a value of 360. The adjacent side has a value of x. So we're using opposite and adjacent. Well, which one has opposite and adjacent? Tangent. So therefore we have tangent of 28 degrees equals opposite 360 over adjacent x. From here we just need to solve for x. I start by multiplying both sides by x, giving me x multiplied by tangent of 28 equals 360. Just like in the last problem, we have multiplication occurring between the variable x and tangent of 28. So I'm going to divide both sides by tangent of 28. On the left, they'll cancel, and we'll be left with x is equal to 360 divided by tangent of 28. If you enter this in on your calculator, you'll end up with the final answer of 677.0615275, repeating onward for quite a while, meters. So I'm just going to round to the nearest whole meter, which is 677 meters away. So the ship is only 677 meters from crashing into the cliff. All right, guys, thank you so much for watching today. If you have any questions, please let me know. I'll be happy to answer them. But have